Let us come back to our original discussion of the project. In this project, we just now have built the final data set or created the final data set that is ready for model building. In credit risk, we do not use advanced methods. Everywhere, in every bank in this world, we use something called logistic regression only. The reason for it is logistic regression is easy to explain. What is the impact of each variable? That is also easy to explain. Due to that reason, due to its interpretability, we can easily show it to regulatory authorities. That is why logistic regression is preferred in credit risk models. So how do I build this model? Import stats models as SM, and then I will also use train test splitting from sklearn import train test data. We will build the model on train data, split it. We will take the whole data into one and then split it into train and test, build the model, validate it on the test data. So my X data is serious delinquency, serial number. Those two are the variables that I'll drop. So if I look at the column, serial number, serious delinquency, except that everything else is a X variable and Y variable is this. Now let me create X train, X test, Y train, Y test, X train, X test, Y train, Y test. Test size equal to 0.2. What does it mean? What is it trying to tell? What is this parameter trying to tell us? Test size equal to 0.2.
80-20, just
80%
checking
is
it.
train data, 20% is test data. Random state 111. That means if you take any random state, all of us in the classroom will get the same train and test data just to regenerate the same random samples. Otherwise, every time they create a new random sample. To avoid that, we are using a kind of seed. So if everybody chooses this number, almost all of us get the same train and test data. Then I will build my model. My model is equal to sm.logit model.summary. This is the summary. And then as soon as you're built the model, model building is only half of the job. Model building must be followed by what? Model building must be followed by
Model
model
validation.
validation. So model validation measures our accuracy, confusion matrix, and so on. Let us see the accuracy of the model. So first I'll get the predicted values on the train data, predicted values on the test data, and then from sklearn confusion matrix, let me create the confusion matrix. From sklearn matrix, import confusion matrix. This is the confusion matrix, and the accuracy on the train data is equal to, you can use accuracy score as a function, or you can use this plus this divided by overall number of records. 93% is the accuracy of the model on the train data, and then test data, confusion matrix, and then accuracy. Test accuracy is also 93, train accuracy 93. It looks good. Overall model accuracy wise, it's fine. There are a couple of steps that we have to take. Build the model, have a look at the accuracy. In logistic regression, we have to take a couple of more steps. What is it? The variables, feature selection, feature elimination we have to do. There are two steps for that we will take. One is multi-collinearity check. How do you check for multi-collinearity? What is the measure that is used for
VIF,
checking
VIF
VIF.
greater than 5.
VIF? VIF greater than 5, it indicates that there is multi-collinearity. So let me create the VIF function. So import stat models API as SM. I'm creating the VIF function, DEF, VIF calculation. Already directly you can use the function that I have given in the classroom, but even if you want to create, it's not a big deal. You take the input data, you take the dependent column from the user, and then you get all the input variables, that is input data dot drop. You drop the dependent column, and then X variable names are this. And now you try to write a for loop for I in all the variable names. Y variable name is, let's say if I is 1, the first variable will be the Y variable, rest all will be the X variables. X variables, whatever are the names, what is the I, that variable I'm going to drop. Variables dot drop. This is the variable. And then build the model, get the VIF value. That is the VIF function which we can use for calculating VIF. So simply what I'll do is I will say VIF calculation, and then serial number not required, and target variable is this. This will give us all the VIF values. For utilization, VIF is 1.0. Like, looking at this output, what do we say? What is our takeaway from this output? What is your final takeaway from this output?
Less than 0.
VIF, based on VIF, how do we choose?
Greater than 5.
VIF
Greater than
greater than 5 is a danger sign. Are there any variables with VIF greater than 5?
No.
No, sir.
No.
No.
So almost all the variables are independent. So sometimes you have dependent variables, sometimes you have independent variables. Here, almost all the variables are independent because every variable is carrying independent information. Age has nothing to do with real estate loans, has nothing to do with monthly income. All of them are independent. Does that mean all the variables should be in the model? After checking independence, what do we check? As a general rule of thumb, after checking independence, what do we check?
P
P-value.
value.
We check for the p-value. You are on right track. Good. P-value will tell us what? The individual impact of the features, isn't it?
Yes, sir.
On Y. We have discussed this in the classroom. P-value will tell us the individual impact of the features on the target variable Y. So let us have a quick look at the output once again. This is a model that we have built earlier. SM. Yep. Just to be on the safe side, I'm also importing this. So based on the p-value, how do you pick and choose the variables? How do you pick and choose the variables based on the p-value?
Less
Less
than
than
0.05.
0.05
Less than
0.05.
0.05 should be kept, greater than 0.05 should be dropped.
drop.
What is the variable that is having greater than 0.05 p-value? Where is the p-value? Here is
Depth
the
ratio
p-value.
new.
That ratio new is the variable that need to be dropped. So finally, if I have to drop the variable, my final x is equal to loans data. So let me say I have reached a phase of final model here. I will see the final accuracy, final model, final model. Okay. Final model will be you have drop depth ratio also you need to drop. Dropped depth. What is the variable name that we need to drop? Depth ratio new. Okay. Based on p-value. Based on p-value. What is our limit? P-value limit greater than 0.05. All right. Let's go here. X is equal to loans dot drop this. And then, you know why I'm dropping these three? Serious delinquency is not part of X because it is Y. Serial number. Do you think serial number should be used in model building? Doesn't make any sense. Credit risk model has nothing to do with serial number. That ratio you dropped based on the p-value. So finally, if I take my X train, X test, Y train, Y test, this is all the four variables or the four data sets. Now I'm ready to build my model. My final model will look like this. My model equal to sm dot this one. This is the model summary. All the variables are impactful. There is no variable which is having more than 0.05 p-value. Now let me look at the train accuracy, test accuracy. So train predicted values, model dot predict, test predicted values are ready. Then I would say train accuracy, train underscore accuracy, test accuracy, train accuracy 93%, test accuracy also 93.66%, which is looking good. But you know what? Model accuracy looks good, but in reality, you need to be a little careful. Can you tell me? I should not be very happy just by looking at the accuracy always. What is the hidden issue that you may face sometimes?
Overfitting. Overfitting.
Overfitting, but overfitting means train accuracy is high, test accuracy is extremely low. The model is not overfitted here. So overfitting is taken care. Because if the train accuracy is 93%, if the test accuracy is, let's say, only 80%, then that model is overfitted. Train test matching overfitting is taken care of. What is the other issue that you also need to take care of?
Like how much my model is predicting the case like 0 or 1 or A or B.
0 or 1 or A or B, class-wise accuracy.
Class
This
wise.
is overall accuracy. Overall accuracy looks good. But if we look at class-wise accuracy, class 0 and class 1. So in my case, class 0 is like good customers, not seriously delinquent. Class 1 is like bad customers. I have less bad customers. Bad customers who will take away my money. Now we are building the model for what? Identifying zeros or identifying ones? Why are we building the model?
One. Is one. One.
Identifying ones, bad customers. So that means
Yes.
which accuracy I'm interested in. Class 0 accuracy is very important for me or class 1 accuracy that is very important for me.
Class 1 accuracy.
Class 1 accuracy.
This is very important. Overall accuracy is also good, but that is not that very important. You have overall accuracy that is based on class 0 and class 1, not very important. Always, what is important, what is your client is asking you all the time? Class 1 accuracy. Shall we do class wise accuracy? Let us see. Class wise accuracy on train data. First, look at the confusion matrix on the train data. Confusion matrix on the train data, or let me call it as, yeah, CM train data. This is the confusion matrix on the train data. Now, class 0 accuracy. That means this element is CM00 divided by this plus this. So, class 0 accuracy, let me print it. Class 0 accuracy. Class 1 accuracy also calculated. Very good. Thanks to Gemini giving us the code. Class 0 accuracy, class 1 accuracy. Now tell me what is class 0 accuracy? What is class 0 accuracy of your model? Overall accuracy
99%.
93%.
99%.
Overall accuracy 93%. Very good. No doubt. Class 0 accuracy 99%. Very good. No doubt. What is class 1 accuracy?
15%.
15%. What really matters to you? Tell me. Is it class
Class
0 accuracy or class 1 accuracy or overall accuracy? Which one are
Class
you
1
real?
accuracy. Class 1 accuracy.
So this is our discussion with the client. Your client told you what? Class 1 accuracy is very important. Now we are giving an output like this. Check this out, all of you. The current situation of the model that we have just built looks like this. Overall accuracy, is it very important? Not important.
No, sir.
So this one, do I really care?
No.
No, sorry, not interested. Class 1, good. Is it important? This is
No.
also not very important. So do we really care? No. Class 1, which is bad, is it very important?
Yes.
Very important. What is the accuracy of the class which is very important for you? Class that you
15%.
are really looking
Class
15%.
for?
1.
15%. Is your model in a good shape right now?
No.
No.
No, sir.
15% accuracy, is it accepted in the industry?
No,
No.
sir.
Pretty
Greater
poor,
than
isn't it?
80%.
Better than 80% is deserved. Here we are getting only 15%, not even a 50%. So the reason for that is there are too few guys. Let's say if you look at the serious delinquency in last 2 years, if you look at this variable, if you look at the target variable Y, the reason why the model is not able to find or not able to give good accuracy in that class is if you try to see Y value underscore counts, I hope this works on the length as well. Let me look at the length later on. First, let me see the value underscore counts. How many zeros are there? How many good customers are there? How many good customers? 1 lakh
1,39,900.
39,000. How many bad customers are there?
10,000.
10,000. So the model naturally will take all the patterns from where? Naturally, it will learn from everything from class 0
Train
only.
data.
That is why it is trying to do its job. Like what percent of the classes, what percent of the customers are having class 0? What percent of the customers?
93.
93.
93. What
93%.
percent of the customers are having class 1? Nearly like
6%.
6.6,
6.6.
which is like
2.6.
7%. So this problem is also known as what? This is a typical problem if you have class 0, class 1. This,
Underfitting.
this problem is known as class imbalance. It
Imbalance.
is not underfitting. What is underfitting? Now that we are discussing what is underfitting, underfitting means the model is having very less accuracy
Accuracy.
on train data as well as less accuracy on test data. That is known as underfitting. So what the problem here is not the underfitting. The problem here is class imbalance. What do you mean by class imbalance? One class is dominating, the other class is having very few records. When you are working with email campaigns, if you have sent emails to 10,000 people, responders, not responders. Do you think 5,000 will respond, 5,000 will not respond? Does it work like that?
No, sir.
No, very few will
Very
respond.
few.
A
Yes.
lot of people do not respond. Similarly, here 97%, 93% are of one class, 1%, like remaining 7% of other class. There is class imbalance. That is the reason why your model, the class that you're really interested in, is giving you only 15% accuracy. Maybe if it gives me 30, 35, 40, above 50% at least, that means half of the bad guys, if I'm identifying, anyway, they are less in number. A lot of people are good guys. So I'm already safe. If 100 applications are coming, how many of them are already good? Out of 100 applications, if I give 100 loans, already I'm at a good position. Why? Because out of 100, 93 people are good people. Yes or no? In the
Yes.
population, do you think in the real world there are so many good people than bad people? A lot of people will pay back rather than not paying back. But out of the remaining 6 or 7%, I want to capture as many as people so that I can mitigate my losses. So I have to do class imbalance handling. So I have to increase this count to a larger number. I have to expose more of these data points to my model so that it can learn the patterns from here. So what is the technique that is used for handling class imbalance? What is one of the best or the most prominently used good technique for handling class imbalance? For handling class imbalance, what is the technique that we
Stress
use?
imbalance.
So there are 2, 3 techniques that we have used, but there is one proper technique that we should be using in the industry. What is it? The one that used by several industry
Smote.
experts. S
Smote.
M O T E. It stands for synthetic minority over sampling technique. What is minority? What is a minority class here? What is a majority class? What is a minority class here?
Majority is
Majority class
zero.
is
Zero.
0. Minority is.
Minority is class one.
What does synthetic minority class oversampling means? What does oversampling means? This is synthetic minority oversampling. What is oversampling mean? Oversampling means you are repeating those samples, you are taking duplications of them. So you will try to repeat the records, these 10,000 records, you'll try to repeat them, but you are creating synthetic samples in that. Synthetic means newly created data points based on this data that is given here. So how do we use more techniques? So from the package imbalance learn dot oversampling import SMOTE, and then I will create an instance of this SMOTE. Sampling strategy is 0.6 means whatever is the number of zeros, at least I want to keep at least 60% of them as ones. Right now, 13,000 are zeros, only 10,000, 1,39,000 are zeros. Tens are ones are only 10,000. That means 13 times you have more zeros. I don't want to have that. So if there are 100 records here, I want to keep minimum 60 records here. That is what it means. Sampling strategy 0.6 means I don't want to keep 100 out of 100 here. If there are 100 records here, I don't want to keep 100 records here. At least 60% of them. If there are 100, I would like to have at least 60 of them here. Random state 44 means the same sample will be repeated if we are using the same ID. So these are the newly created train SMOT samples. So if I try to see before and after SMOT, what is happening in Y, there is a simple package called collections. This is another alternative to do value counts. Let me do value counts only without any confusion. So before SMOT, we have done the value counts Y underscore train dot value counts before SMOT in the train data only. Earlier, I have shown you the full data in the Y train data. Now, if I try to see after SMOT, if I take Y train and then what is this? Y train SMOT and value counts. So from ones which are 8,000, zeros which are 1,11,000. I have made 8,000 into what? 67,000. By default, it will make 1,11,000 are there. It will also make 1,11,000, but it is almost like we have made the data 8 times. Why are we doing it? Because the class that we are interested in, that class accuracy is reeling very, very low. I want to move it maybe from 15%. If I can move it to 30%, I'll be happy. 35% more happier. 40% very happy. 45% even more happier. So I want to increase the accuracy of that particular class. So I'll try to build the model on this new data set, newly created data, which is X-train SMOT, Y-train SMOT. So let's build the model on this new data set. Let me call that as model building on balanced data, which is a SMOT data. So I'll say my model is equal to sm.logit X-train SMOT, Y-train SMOT. Overall, the variable impact won't change all the p-values, like everything will remain the same. However, the model will have a slightly better accuracy now on the class 1, which we are confusion matrix and accuracy score. So you have train predictions equal to model.predict. Test predictions, we can see them later on. Confusion matrix, train underscore CM are these ones. Confusion matrix is also with us. If I try to print the confusion matrix, I'm expecting slightly better confusion matrices. More number of ones are predicted. More number of ones are predicted. The mistakes that we are doing here are reduced. But the thing that I'm interested, class 0, class 1 accuracy, class 0 and class 1, class wise accuracy, class wise accuracy on train data, class 0 accuracy, class 1 accuracy is equal to train data underscore confusion matrix 1 1, class 0 accuracy, class 1 accuracy. Earlier, class 1 accuracy, we were very disappointed with the class 1 accuracy of how much percent? 15%. So this was a situation, I would say, as is situation was this one before coming here. So I would say before SMOT. Let me say the situation after SMOT. Class 0 accuracy and class 1 accuracy is given here. All right. This is the one. Class 0 accuracy, we don't really care. Even if it is reducing also, it's not a big deal. But class 1 accuracy from 15%, we have increased it to 55%. Like the improvement happened almost like 4 times or 3.5 times improvement, which is a very big improvement. And we will try to do all the other ways of feature engineering, etc., to improve this as much as possible. But the one technique that will give you the lift or will focus on the target variable more is the SMOT technique. This is the one that you will use for improving the accuracy of the particular class that you are looking for. So as I told you, when somebody asks you, what are the challenges that you have faced in the model building, or if somebody asks you to describe the model building phases that you have used, always go in this particular streamlined manner. What is a streamlined manner? Explain a couple of points about problem statement. Explain what are some of the variables that you have used. Maybe give an example of couple of examples of issues that you have faced. You have a variable called monthly utilization, which has 3% issues. Some of the values are going very high. Explain a couple of methods of cleaning that you have done. You have used imputation in some places. In depth ratio, you have used uh, imputation as well as flag variable creation, etc., etc. So that was one of the biggest challenging part. It took a lot of time for me. You can explain in that manner. And then model building, explain a couple of steps, and then multicollinearity checking. Based on multicollinearity, we drop the variables, and then based on p-value, we drop the variables. Finally, once we guys validate the model, what we found the biggest issue is the class that we are looking for due to class imbalance issue. The class that we are looking for, class 1 accuracy, is very less. And then finally, we dealt with a SMOT technique to improve the accuracy of the class that we are looking for. So those are the steps. If you mention like that, the other person who is actually trying to gauge or trying to assess you, they'll get to know that yes, you have working experience of working on all these techniques. The reason why that I do not touch some of the academic techniques that are very much discussed in the outside world is those techniques, what works perfectly in academics may not be always appreciated in the industry. We need to be a little careful. Always, we would like to showcase our experience as industry specific or industry oriented experience rather than academic experience. Okay. So that is the story of the project.